Assalamualaikum and have a good day. My name is Mama Zaimul KAHAR, B0918102101. I'm a Bachelor of Mechanical Engineering Technology with honor. My supervisor is Dr. HAZWANI BINTI MOKHTAR. My title of this PSM2, which is Design and Flow Analysis of Shower for Bedridden Elderly and Patient. So we go to the background. For my background in PSM2, we discuss the several people above the age of 65 are bedridden due to age-related problem, and ordinary people also are forced to be bedridden due to various problems such as paralysis and vision accident. And next, unable to perform partial or full self care and medical treatment and require support from others. And my problem statement in this patient 2, which are giving a bed up to bedridden patient, is very limited and reason for caregiver and bedridden patient, and it require caregiver to effort to perform the operation. The current method that the caregiver use for giving a bed to bedridden patient is a conventional method, and this method makes the time taken to give bed to the bedridden patient longer. Generally, there are less contribution to the bedridden community. My research objectives and which are create the new design of easy shower for patients who are bedridden, to use simulation to evaluate the performance of a design model for a bedridden elderly and patient, and to compare different value simulation of velocity set with a bedridden model design. So actually my scope in this project, this study will use simulation process to design and analyze the design shower and evaluate the different value of velocity set with the design for the bedridden LED and the patient. So we go to the lecture review. What related with my PSM2, which are Tony and Lund 2008, started that bedwetting can help manage the hygienic to bedridden patient with two method, which is cultural awareness and personal preference. Caregivers should consider lady and patient preference so that the bedridden will be in comfort condition. And then another one is privacy and dignity. To confidential and even set a procedure, and then patient may feel uncomfortable or even irritated. So I will go to the methodology. It has been discussed in patient 1. In this design A, design B, design C, and I already choose design A because we can see the hydration method result. Total score for each design can be obtained after all the value are given. Value of each design are given and all the design criteria. And design A has the highest total actually. You can see in the green line. So from the result, we can specification to the ranking and weighting. And on this specification, I choose three highest, which are cleanliness of patient, easy to handle and easy to use, and lastly strength. Actually, strength is very important for bedridden, but we must to input we must to focus on the cleanliness of the patient. So next is after the result, we go to the final design. So final design A obtained the highest score and had been chosen as the design that will be on simulation. There are some modifications that had been made on the design A. On original design A, it has a 1 water inlet and a 7 water outlet. which are the sprinkler, and the position of the water inlet and outlet is different actually. So in this flow simulation, I provide only a two simulation, which are water inlet sprinkler design model and water inlet main pipe of part B design model. Why I choose the part B? Because it has been split by four, uh, which are part A, part B, part C, and part D. Why I choose part B? Because it actually the same result with part A, part D, part C. The initial result are same and final result. So we go to the boundary condition of a water inlet sprinkler design model. So for the question, I will discuss the parameter that I choose 0.5, 2, and 5 meter per second. And then the boundary condition in the analysis type, I choose the internal. Fluid, I choose the water liquid. Default wall thermal condition, I choose the diabatic wall. And pressure, and actually pressure the environment 1.1325 Pascal, and temperature is 293.2 Kelvin. So I choose the in the right figure. I choose the inlet velocity, and, and then we go to the boundary condition of the water inlet main pipe of part B design model. So on this parameter is same with the water inlet sprinkler design model. In boundary condition is same too with similar in parameter water inlet sprinkler design model. Analysis type, fluid, this default water thermal condition, pressure and temperature. In flow simulation, why I choose the right? Because that one initial flow actually in inlet velocity. So we go to the result and discussion. Flow analysis, for this I discuss the flow analysis trajectory simulation water inlet of sprinkler design model. So it show two types, which are velocity and pressure. So I will discuss the 0.5. For the initial result, I got 0.446 meter per second with similar sini. And then 2 meter per second, I got 1.769. And then lastly 5 meter per second, I got 4.4 to 7 meter per second. And then the pressure for the 0.5 meter per second, I got 11,446.61 Pascal. And then for 2 meter per second, I got 376077.97 Pascal. And then lastly, for 5 meter per second, I got the pressure 1799710.48 Pascal. Why velocity and pressure flow was different? Because velocity initial was slowly, but the orifice sprinkler, which is a nozzle, inside nozzle, was higher, and then the pressure was the initial result was higher, but in orifice sprinkler was slowly pressure. So we go to the flow analysis, flow cut plot, water inlet, main pipe of part B design model. So I divide by three parts, with part A, part B, and part C. So this is a pattern of the flow analysis cut plot of velocity in 0.5 meter per second. So I will discuss the graph. For the first sprinkler in 1.66 meter, I got 0.597 meter per second, and second sprinkler, I got the 0.472 per second in 1 meter. After final result of sprinkler, I got the 0.236 meter per second. And then the pressure was same, and the same method, have a part A, part B, part C. And then what we can see, the pattern, part A and part D has different, but part C was similar. And then the graph, I will discuss the initial final. I got the 0, 1, 04, 3, 360.48 Pascal. But in the middle was same actually, 0.0104316.555. But in lastly, and the result of pressure was slowly actually, and which is 1.4 to 77.21 in 2 meter per second. And the part A, the pattern was similar. Part B, much different, but in part C, was a similar result. So the first sprinkler actually, I got the 2.31, and second sprinkler, which is 1.49 meter per second, and lastly I got the 0.75 meter per second. While the pressure, the part A was a different result, but part B and part C was similar result. So for the initial, and in this analysis, I got the 147,608.4 in initial, but in the middle, and it was a little result in 1.45 meter and 1.46 meter, but it has the same pressure actually. And lastly, the final result with same result with the part B in the middle sprinkler, which is 147,199 point 83. And then lastly, for the velocity in 5 meter per second, part A, the pattern was similar, but part B has been changed because of this what we call the vortex, and the part C quite similar. And I will discuss the first sprinkler, and which is 5.74 meter per second, middle 3.71 meter per second, and lastly 1.87 meter per second. While the pressure, I got the different result with part A and part C. And then in the graph, you can see the different result in 9.69 meter, and 1.46 meter, and 0.97 meter. But it was same flow, same pressure, in condition of 0.8 to 607.62. So in general calculation of pipeline loss of the main point of the part B is a model. This calculation use the HAZWani equation to determine the pressure loss due the pipe friction. So this is a parameter of main pipe of the part B design model. So in this, after I calculation, I got the by velocity 0.5 meter per second, I got the 0.026 psi. In velocity 2 meter per second, I got the 0.324 psi. And lastly, velocity 5 meter per second, I got the 1.8849 psi. So based on the theoretical calculation, a critical factor in the ability sizing a plumbing system, engineer will correct for the friction actually, which can reduce the pipe pressure and interrupt the fluid flow by upsizing the piping system or boosting flow velocity in the design. So after the result, I will discuss the parameter for the simulation of water inlet sprinkler design model and water inlet main pipe of part B design model. All result obtained were within the value of velocity set, which is 0.5 meter per second, 2 meter per second, and 5 meter per second actually. Ensure that the design model is convenient with the parameters set and the boundary condition chosen. So conclusion, this thesis present a new design model of actually easy shower for the bedridden patient. The process of design and simulation has been done by using SolidWorks software. And then lastly, the proposed methodology is effective in order to obtain a good result, utilizing only fairly accurate. So that's from me. Thank you. Assalamualaikum.